So hello everyone, good morning, good afternoon, or good evening, depending on where you are located. Thank you for joining us for this webinar organized by the Canadian Geotechnical Society, Young Professional Committee. My name is Alex Almeida and I'm a design engineer with Keller. I'm based in Toronto, Ontario. I am a member of the CGS Young Professional Committee. Unfortunately, Rajesh could not be here today, so I'm moderating this webinar by myself. The CGS Young Professional Committee initiated this webinar series to allow young professionals to enhance their knowledge in a range of areas of geotechnical engineering. This is our sixth webinar in 2023. If you're interested in listening to past and today's presentation, the recordings will be available on our YouTube channel. I will post a link in the chat shortly. Before we get started, there are a few housekeeping notes that we gotta go through. To avoid any disturbance, audio and video access has been disabled. If you have any questions, please use the chat. The presentation will take about 40 to 50 minutes, followed by a brief questions and answers session. If you have any questions for the speaker, please type them in the chat. So today we have Naresh Gurpersaud. He's a professional engineer in Canada. Naresh is the chief engineer for Keller Canada. Naresh joined Keller at the time operating as geofoundation contractors in 2003 and completed numerous projects across Canada involving specialty grouting, ground improvement, and foundation support. He has over 40 technical publications related to specialty geotechnical constructions and techniques. Naresh is keen on the advancement of the state of practice of specialty geotechnical construction techniques. He has been involved in an industry collaboration with local universities on research and development projects. A few notable projects Naresh has worked on include the transformation of the Art Gallery of Ontario, Niagara Tunnel Project, West Toronto Diamond Rail-to-Rail Grade Separation Project, and Hebron Gravity-Based Structure, GBS. I have the pleasure to have Naresh as my mentor in Keller and enjoy the presentation. Naresh, I get it over to you now.
Yeah, thanks, Alex. Let me just get us started. Yeah, thanks, Alex, for the introduction. And
Naresh is still on the other side.
Okay, sorry.
That's okay.
Yeah, I'd like to thank the committee, the CGS Young Professionals Committee, for this invitation to talk today on specialty grouting and ground improvement. So, sorry, let me just flip this back to presentation one. Bear with me one sec. Is that good, Alex?
It's coming up. Yeah, there you go.
Okay, yeah, I'll get started. I usually start with a safety slide or quality slide, but for today's presentation, I want to get started with sustainability. It's important. It's a key focus for us here, and it's there's been a lot of attention being paid to sustainable solutions. The various components here are economic viability, environmental protection, and social equity. As we go through the solutions that I'll be talking about today, it's important to focus on aspects such as reducing a carbon footprint and thinking long term in terms of sustainable techniques and sustainable development. So for today's presentation, we'll focus on an overview of grouting, the various types of grouting, and some of the ground improvement technologies. I won't be able to get through all of the technologies and our techniques in details, but I'm trying to give you a general overview so that you can have an understanding of these solutions and some of the case histories. Case histories that have been, based on projects completed across Canada. So specialty grouting, it covers a wide range of applications, such as slurry grouting, chemical grouting, compaction, jet grouting, fracture grouting. There's a lot of variability, especially in soil profiles, right? Based on its complex nature. Sometimes you may have to combine some of these solutions based on the actual conditions or any changes encountered during the execution of the work. But they're definitely technically viable solutions, and they can be implemented in numerous projects or challenging conditions, especially if you need to do any type of in situ treatment or stabilization. I've boxed out jet grouting here, as you can see from this profile. Your grouting solutions can take care of various soil types here. Compaction grouting, the range of application, and for instance, compensation grouting in silts and clays. But you can see here with jet grouting, and I'll be focusing a bit more on jet grouting just because of its versatility, but I'll be touching on other techniques as well. So the jet grouting process, it involves the advancement of a small diameter hole to the target depth of treatment. And upon reaching the target depth, the jet grouting system is engaged, which is a high pressure pump. And the injection of cementitious grout begins from the bottom up, and it blends with the soil in situ to create a soil cement matrix. And you can tailor that matrix to suit your need or your performance requirements for a project, whether it's water cutoff, soil stabilization, environmental containment, structural support. It works in cohesionless soils and even cohesive soils. You could probably go and perform this work in material more than 80 kPa that may require some additional work, such as pre-cutting or multiple passes. Permeability is in the order of 10 to the minus 7 cm per second. You can achieve a high strength material in situ, which is the soil cement matrix. It's the system itself and the process requires experienced personnel. And then during the installation of these jet grouting elements, you're generating some amount of backflow or spoils, which are basically the material that you've blended would be conveyed to surface. A lot of times you get questioned about pressure grouting. This thing is open and it's you have a continuous return of spoils to surface. So it can be used for underpinning of masonry structure. So it demonstrates the level of control that you can have by using jet grouting system. So there are various systems available. You can use perform this work with a single fluid where you use grout only, but the commonly used system involves the air and grout. So the air shrouds the grout nozzle, and then there's a triple fluid system where you have you add water to the process by water and then the application of grout. So you have air, water coming through one port and then grout the following port. I just want to stress talked about the versatility of the system about creating various geometries. You can see here full partial columns, panels. You can modify your installation to suit your target treatment profile. Some of the applications, scar protection for underpinning of structures. If you want to pre-treat the section for tieback installation, bottom struts, or bottom plug for excavation. Shafts. You can essentially create a complete bathtub with this underpinning of masonry structures. Shear panels on tunneling applications. It's important to capture your installation data. A lot of the work we do, it's you don't see it. It's hard to most of the subsurface applications. So the data acquisition system captures your installation parameters, and you can look for any type of anomaly, variation in your installation parameters. It's important to see or understand what's going on behind the curtains, especially for installation of elements and any changes in your drilling or your grouting phases of the work. Most of the interesting developments would come out of field challenges or field issues. So it's important to continually advance the state of practice. And for instance, the acoustic column inspector, it's a system that was developed internally by Keller. And the basis was to, establish the profile of the jet grout element during installation. Prior to this, most of it has been done by exhumation when possible, or coring, or some type of feeler pipe. So this has been an advancement where you can log, listen, and see the extent of the contact from the the jets during the installation, sort of a real-time feedback to confirm. In addition to this, you can still core or perform additional verification checks. What's useful to have this data, and you can establish whether you're maintaining your nominal column diameter profile that's required for your project. I've got through a few case histories now. This is a jet grouting project that was done in Ottawa. Some of you may be familiar with the street and what occurred here a few years ago. The jet grouting was performed pretty tight setting, restricted access, sort of, because it was along an existing roadway. On this site, we were able to process the backflow on site using a centrifuge in the system that you can see on the right. The depth of treatment was approximately 30 meters. It requires the setup of a plant, equipment for batching of your grout, your drill rig, you can see in the background here, and setup of the system. Another project that was done in Keswick, Ontario a few years ago, and this was related to tunneling. The proposed new tunnel is getting in close proximity to the existing tunnel and a very soft profile. There were concerns about movement, settlement, disturbance of the existing tunnel. Jet grouting was performed here, and within the box area, you can see where the sewer crossing is, right beneath an existing roadway. It was done to create a profile shown on the right to support the existing tunnel, and to create a stable block to allow for the advancement of the new tunnel. There were some stringent requirements within this area. There were, there was an extensive monitoring system, subsurface monitoring points, and the work was performed. After the jet grouting was performed, then tunneling was completed without any issues here at the crossing. Another site in the Toronto area where they were using a system comprising of PT interlocks on a project. The challenge with the PT interlocks, because of the installation process, the interlocks were damaged This was meant for a watertight cutoff or for a permanent retaining wall. And because of the damaged interlocks, they were unable to flush and clean the interlocks to install or inject cement bentonite grout to the full depth. So here again, jet grouting was used, on the close to the interlocks to create a secondary low permeability barrier to at locations where they have deformed interlocks. And there were quite a few locations where these interlocks were damaged. You can see a profile of the site, at several locations behind the existing the pipe pile wall with the PNT interlocks. Jet grouting was performed, as you can see from the final excavation profile. The sections here are fairly dry. Other applications, cut-off walls. If you have sections of walls where you need to treat a specific layer, instead of doing a top-down treatment, you could target that specific zone where the treatment is needed. This is the site in northern Quebec where they're constructing new generating stations. In order to do so, they had to construct 2 cofferdams, like upstream and downstream. And the intent was to treat the zone or make it fairly watertight, the layer below the upper clay section. Jet grout columns were installed. We'll get through all of the individual applications here. We'll bypass this. To create, there was the final excavation profile. You can see where, both jet grouting was done both to the upstream and downstream cofferdam for this project. Excavations, dry, sort of bone dry here. Photo was taken at the final depth of excavation. Move on to compaction grouting. Another type of grouting that utilizes a low mobility grout or grout that can be placed, a low slump grout, to create this bulbing effect, as you can see here from the animation on the right. The intent here is to pack material, filler material into the ground that can be used for void filling and densification. So if you have voids or loose sands, or any type of disturbed ground conditions, a lot of the work we do where compaction grouting is needed, there was some amount of ground loss, broken water main or tunneling application, or something that triggers some disturbance. So you can get in there and there may have been some fill or temporarily placed material. You can get in there and densify specific layers. You need it works well in a sandy profile, and it can be done in a low headroom condition as well. Compaction grout mix, as I said, it's a filler mix. A low slump mix, and that is pumpable. You want to try and have the ability to inject and get in place. Unlike the grout for jet grouting or cementitious grout injection, you don't want a grout that would run away or permeate the ground, but laterally displace it during the installation process. It's usually done in lifts. So you work your way. You advance a casing to the bottom of the treatment zone, and that casing is extracted in lifts. And for each lift, you have a refusal criteria that you're trying to achieve. Here again, it's important to have some level of visualization of the work that's being performed. You can look for trends and patterns of the grouting. An area where you may need additional treatment, whether you need secondary, tertiary. You can see the order of holes here. primary, secondary holes, tertiary holes in some areas. So it's sort of a dynamic process where you obtain a lot of data during the installation, and you could modify your program based on what you collect, because you'll have your data from drilling, which is a case hole, but you can log some general information around conditions and things like that. But it won't be as detailed, as boring, and your volumes and your pressure. And so a review of those data can really help to drive or optimize the program to meet the performance requirements. A project that was done in Cork, Ontario. You can see here, this was an emergency job. They were tunneling below tracks here. I believe this was either CP or CN. Sinkholes started to develop. So compaction grouting was performed. And, the work was done around the tracks. They're trying to stay clear of the tracks by putting batter holes as well, and working around the train schedules as well. Talk a bit about permeation grouting. Well, permeation grouting, it's a injection system where you're trying to have, either cementitious grout or chemical grout permeate the soils. Must have suitable soils, but low fines content. The intent is to slowly work your way up, and that's done using a sleeve pipe system. I'll get into the so a hole is drilled, and then you have a sleeve pipe with multiple ports. You can see the way the sleeve pipe is configured. Once the sleeve pipe is installed and you have a low strength annulus grout, you can come back in multiple times. Perform this work in multiple phases, and target specific layers as well. So the ports would open, and you do that by using double packer assembly, single packer for the bottom port, double packer assembly. So you're targeting individual ports. So in terms of the grout flow may migrate in different layers, different directions. But you can sequence this work. It's slower than other grouting techniques, but in some applications it's neither necessary. Whether it's access, confined areas, tunneling applications. There's definitely applications for you'd see for the permeation grouting. This was a project that was done in the early 2000s in Edmonton. It was part of the Edmonton LRT project. You can see a shotcrete wall here, but there were other areas where permeation grouting is required to support and protect utility corridors, to facilitate the excavation and construction of the launch shaft. Niagara Tunnel project. At this site, rock fissure grouting was done. I think most people should be familiar with this location, but a lot of folks are not familiar with the structure that's upstream of the falls, because you get there and you see the structure upstream of the falls, which is the International Niagara Control Work Structure. What it does, it regulates the flow over the falls during the day and night, and it also works in terms of controlling the diversion of water for power generation at both the Sir Adam Beck generating station and generating station in the US. So there's a fair bit of control that takes place here during the day and night. The new tunnel was constructed. Construction started, I believe, in 2006. The work that was performed was done in the intake structure, or the excavation, prior to the excavation of the intake structure. And you'll see the intake structure was constructed. Here's the INCW structure that was shown in the previous slide. The location here at Cofferdam was constructed. That was necessary to commence work here. So for the tunnel would have exited within this zone. This was really an exit portal. What was important here, prior to that, dewatering and excavation, there were several layers here that required treatment. If not, it would have been extremely difficult for them to control the inflow of water into the rock. There are 2 or 3 highly permeable layers or where water would have flowed into the excavation. So the grout curtain was installed around this entire cofferdam, including along this alignment here, up to depths of 50 meters, where cementitious grout was injected in stages, and the holes were done in a sequence approach where you had primary, secondary, tertiary. And during that process, there was an extensive amount of data collected, data was reviewed, water testing, and evaluation to confirm that continuous curtain was installed prior to the excavation commencing at the site. Here again, it's important to capture data that's of the installation, which can also be used to monitor and evaluate the effectiveness of the grouting and help to control our develop path forward based on trends that you're seeing, the amount of holes and areas to target. So it's a display of our data acquisition system for cementitious grouting. I'll move on to wet soil mixing. Which is a process of mechanically blending soils using cementitious grout. Like jet grouting, this is done with rigs with the mixing tool, and you can create various sizes of columns by blending it with cementitious binder. Typically, it's a grout. Works good for cohesive soils, cohesionless soils, various range of post-treatment strength. This work is done with larger size rigs because unlike the jet grouting where you go with a small diameter installation and create a much larger element, with the mixing process, you're advancing a mixing tool top down to create various geometries, columns. I want to touch a bit on some lab testing. Here you can see we took some samples of Leda clay. Most people will be familiar with challenges associated with this material, working with the material, low strength material, extremely sensitive. Done a fair bit of testing of the lab with various samples from a few sites on prior in Canada. And, some of the results you see here, the strengths we've developed by using, by blending it, by conducting soil mix trials in the lab. So significant improvement, and it shows you how this technique can be implemented or utilized on job sites where you have low strength, weak material, sensitive soils. The application can be done several ways. I'll start with mass mixing. With the mass mixing technique, you're mechanically blending the soils with a mixing tool or an attachment, and this attachment can be part of an excavator. It's an excavator mounted unit. With this system here, this is dry. With a dry system, you're actually just blowing cement into the material, especially if you have peat, high moisture content material, you can utilize that. The water that's present there and just blend it with cement. In other applications, you can also run a grout slurry and use the same setup to treat depths up to 6 meters. There's some limitation of this setup because of the mixing arm and the attachment and depths that you can get to for treatment. There's a case study project done in Edmonton. Mass soil mixing was performed on the site. This was done for some tank foundations. Yeah, dry soil mixing can be done as well, as I mentioned earlier. It can be done with you can perform column mixing or mass mixing for shallower applications. Collection of data. It's important to capture your installation data during this process, just to ensure that you're achieving your target binder content and aligns with what you're trying to having consistent the mix elements or installation in the ground and looking for any type of anomaly or variability or any issues that may occur during the process. More mixing applications. There's wet soil mixing. This is column mixing. This was also done for a project in Fort McMurray. You can see the setup here on the left. For your batch plants, your silos, mixing larger columns, but it's 2.4 meter, 1.8, 1.5. You have large columns, you need a significant amount of grout. Having the ability to batch this grout on site. Some sites may have multiple rigs, such as this one. So you need to be set up properly. And set up for that installation on the sites, depending on your extent of grout consumption. Your silos and batch plants should be adequately sized and set up. Another application for where mass mixing was done. This was done on a site to essentially create a bathtub. This profile here was all mass mix, an entire block. Then the excavation was carved out as shown here. So prior to this, you have, fair bit of organic soils and within the layer, you can see where the water table was, fairly close to the ground surface. And this allowed for the construction of their foundations at the site so you had both of bottom layer that was mass mix on the site, so creating a bathtub at the site. Several benefits of doing that. You get on a site really restricted sites. Most of the developments now, you don't have a large footprint. May not be feasible to put in a suitable shoring system, especially if you need a system with a bottom plug. Here on a site, you can perform this work prior to doing the installation of the piles. So the level of interference coordination work, and another important item is the ability to control water and provide a safe excavation for this work to proceed. I'll move on to vibro techniques. The vibro techniques basically used for densification of soil, increase bearing capacity, shear resistance to reduce sediment, mitigation of liquefaction. It can be done in various ways, methods, and I'll get into some of those details. Typically, the vibro or vibrators use electrically operated vibrator. As you can see here, based on the motion of the the vibrator itself. You have the energy where you need it, and that will be at the treatment location. So as this thing is lower in the ground, whether it's done for stone columns, vibro compaction, or other applications, that energy is essentially focused where you need it, where you're compacting that material in the lifts as you work your way out of the hole. There are various sizes of vibrators that can be used, and these vibrators can be augmented with water jets, as shown here on the schematic on the right. Vibro replacement. This is typically done with aggregates on some type of grid spacing. Could be used for an area treatment. Be used for settlement control, for densification, for liquefaction mitigation. It's whether there's pre-drilling can be performed to facilitate advancement of the probe. In some cases, it's not necessary. The stone can be fed either from the top, as depicted here in the figure on the right, or it could be fed through the vibro string, the tubes, using a hopper. So with that setup, it would be a bottom feed system. It could be done to significant depths. I have here at 36 meters, but I believe if you're set up, you could potentially push this deeper. Effective above or below the water table, and I talked about the two systems that can be used for vibro replacement. The other applications of smaller piers, which smaller elements, you can use those as our vibro piers for embankments, for footings, for MSE walls, slope stabilization, and tanks. Here is a setup for vibro piers. This was a site where vibro piers or stone columns, you can see the piers here depicted in the figure on the right, were installed to support new footings of the site. This was done using the top feed system. With the top feed system, the stone is fed into a hopper and charged through the pipe, or the vibro string gets to the bottom of the hole, and that stone is packed and lifts as you come up. And that data is also captured using a data acquisition system, which most of the rigs rigs in our fleet are outfitted with a data acquisition system to capture your installation parameters. It's also important to test, conduct verification testing, modulus tests on an element. These are piers that are tested to verify your design assumptions. Other systems that can be used, rigid inclusions. With rigid inclusion, they're rigid, unreinforced, typically unreinforced elements used to bridge any compressible layer, and it's used in combination with a load transfer platform. So these are not piles; they're not structurally connected to your footings. Used for settlement control. With the inclusions, they're designed as required, whether it's for foundations or for slab or for the specific applications. Could, as I said earlier, control your settlement to significant reduction in settlements of sites. And, they're usually embedded in a firm bearing layer or firm layer, or advanced to the top of a firm layer. And numerous applications for rigid inclusions as well. Here you can see a photo of rigid inclusions on site where the installation is done. A drill string is advanced using a special tool, displacement tool, and the concrete is is pumped during the installation process. That entire operation is monitored. It's captured using a data acquisition system. There again, you conduct pre-production load tests. You ensure that your installation parameters matches or are representative of the test element. And with most applications, especially ground improvement, it's prudent to conduct load testing, checking your sacrificial elements on sacrificial elements generally, to ensure that you can achieve your target design parameters prior to getting into installation of production elements. So we have several other techniques, cutter soil mixing. It's just a variation of soil mixing using cutters instead of a mixing tool to create columns. With cutter mixing, you're creating panels. Mixing, there are several applications for cutter soil mixing as well. Supportive excavation system, cut-off walls. You can also use the elements for as ground improvement elements as well. The mixing is done using the similar approach where cementitious grout is pumped and the blending of the soil is done as the tool. Advances through the depth of the treatment zone. I didn't talk about vibrocompaction. Vibrocompaction is not a technique, but instead of placing aggregates during the compaction process, we have clean sand, low fines content. You can advance a vibrator that would be used to densify the existing material there, typically sands, and then it would sort of pack that in place, and you have to top it up, or you can add more sand to compact that. Some type of grid spacing of the site. Most of this work is done by verification checks, CPTs typically, where you could verify your pre and post treatment condition. I didn't get into the details about deep dynamic compaction with DC. Weight is being dropped. Typical treatment depths is in the order of 10 meter. That weight is dropped, the number of drops, the number of drop points, location, number of passes. It's all contingent on the soil profile and the level of densification that's needed. There's also rapid impact compaction, which typically gets you to a shallower depth, order of 3 meters or so. But it's a smaller setup with a impact, but it creates impact points. Similar approach for densification. Wick drains. Wick drains can also be used as well, to expedite consolidation of the soils with some level of preloading. The drains are installed on site, and there's some level of surcharge, and based on the time needed and the extent of consolidation, there are applications where wicks is also maybe a suitable technique. Arc-rig drains. Arc-rig drains are used for liquefaction mitigation. Unlike wick drains, these are sort of pipes. So it facilitates the significant amount of drainage, a higher volume. They're robust pipes that are placed in the ground with that are perforated along with a Geotech style liner. Ground freezing. There's been some applications of ground freezing in Canada. Here in Toronto, there's been a few ground freezing projects. We also did some ground freezing in Montreal as well for a tunneling site probably a year ago. Ground freezing in BC. So a few sites, it's a bit more extensive. the setup and the maintenance. But it's an effective technique if stabilization is required in certain zones for a lot of cases. Most of the work that I'm aware of that it's related to tunneling applications where a section may be needed. Some of the sites in Vancouver where freezing was done was like in the middle of a river at a location that was hard to get to perform any work, and quick response was necessary to facilitate or to allow for repairs. Compensation grouting. I didn't get into the details of compensation grouting, but this can be done for tunneling projects where you have a system that you could perform grouting for any type of stabilization, settlement control of existing structure. So as your TBM advances, if you have an extensive monitoring system, compensation grouting can be done to either stabilize or control or limit deformation of existing structures or utilities. So I've touched on a number of things. This is a fairly short session to get into the details. I know this session is tailored for young professionals, but even if you're involved in some of this work for a long time, I encourage you all to think outside the box. Think beyond conventional solutions. Right? We're still seeing a lot of techniques that are being applied where there's a potential to change, to optimize, to value engineer, and use perhaps one of the 20 different things I touched on here today, right? So some of the caveman solutions are still effective, but we need to look at alternatives, right? And encourage you all to collaborate. It's important. You really have, you can get good ideas, good suggestions by engaging specialty contractors. The feedback, the guys who are doing this type of work, they could work along with you, provide support, provide guidance, may have ideas, may have experience doing something similar to your challenging condition or site condition that you may have, or they give you some good feedback in terms of how to approach your targets, right, or your projects. And as young professionals, I encourage you to get in the trenches. Even if you have a PhD, or most of our hires, even guys with folks with PhDs, they start in the field. That's where you gain valuable experience. You have a good understanding of how these techniques are being performed. And as Ralph Beck said, you need to understand the challenges of the builder, because designing is one component. You also need to understand constructability as well. So gaining that field experience would be extremely valuable for your career. You'll be able to also combine techniques and solutions for site rather than having one or a few limited options and trying to make them work for various conditions. Use engineering judgment. We won't find everything we need or all the solutions in the textbook, but sometimes you have to understand what's required and what's best in terms of reaching those targets. I encourage you all to find technically viable and economically feasible solutions. In order to do so, look at multiple solutions for a site. Just don't stick, for instance, driven piles. We'll use driven piles here at a site. when there might be some other options, for instance, that could be feasible, and you can potentially, provide some cost savings to your client while satisfying your requirements. Consider grouting and ground improvement solutions as well. There's several things you can do there. As I said, perhaps 20 different techniques by looking at just grouting and ground improvement, or a combination of those techniques that can be used. There's also some limitations, restrictions these days as in terms of what you can do, in terms of removing or replacing material, dealing with contaminated sites, and getting to the treatment depth, whether it's a grouting application, getting, performing excavations to reach, the target zone. So explore these options, look at it, perform an assessment of the variable options or the multiple options that are available, and try to reduce carbon footprint. Look at what the solution entails and what are your alternatives. What can be done? Look for a sustainable approach. As I mentioned earlier, it's important. We have to look at the processes, the materials, the solutions. Especially during the design phase of this work, or early discussions with your client, contractors, and getting feedback. You can certainly have, you have the ability to come up with some sustainable solutions. And I'll wrap up here. As I said earlier, I like this quote here from Confucius: "I hear and I forget, I see and I remember, and I do and I understand." So once again, this goes back to this is mainly for the young professionals. Try and gain field experience. Listen to the guys on site. That's not listen, but try and get involved. Understand the conditions. Get out for site visits. Try to see what's going on firsthand. Try to understand what the conditions are. Even if you're designing a project, site visits are important. Just don't rely on Google Earth or Google Maps or photos. And with that, thank you. Thanks for taking the time to join here today. I hope you benefited from this session with some of the information. If you got any questions, clarifications, whether it's addressed now, or feel free to reach out to me anytime. Thank you.